Want to ace the TOGAF 9.2 exam and boost your career? In this video, we will break down everything you need step by step, making complex concepts simple. Let's get started. Our learning goals are simple. I want to help you prepare for review and pass the TOGAF 9 Part 1 examination with as much confidence as possible. The course that we have designed has been fully aligned to the approved Open Group certification and study guides for version 9.2. The goal of being able to pass this kind of exam is it demonstrate very clearly to employees and peers your commitment and the knowledge of enterprise architecture as a discipline. So why TOGAF? Well, it is an open group for enterprise architecture. This means it helps avoid lock-in proprietary methods that only some people know and only some people can follow. It brings standards and best practice tools and techniques to the way you design and build and execute on all your projects. And it has a knowledge-based certification program. This means that it can prove to both peers and employees that you have the skills necessary to tackle the next big job. Why TOGAF as a standard? Well, it was community-driven and collaborative approach, and it focused on what matters the most in lowering the overall risks in the difficult-to-plan phases. When you are using the TOGAF framework, it helps you respond to the needs of the business while considering both of the present and the future. Our goal is to explain the information in a simple and easy to understand way. This course covers the following topics. 1. Preparation for the TOGAF Foundation exam. 2. Overview of the structure of the TOGAF standard document. 3. Understanding key definition used in the TOGAF standard. 4. Basic and core concepts of the TOGAF standard. 5. Understanding the architecture development method ADM used in the TOGAF standard. 6. We will explain the latest updates. So this video we are going to be talking about the TOGAF 9.2 certification. 1. The certification consists of two parts. 2. Obtaining a passing score in the Part 1 exam result in being certified with TOGAF Foundation. 3. Passing Part 2 of the TOGAF exam leads to TOGAF certified status. And if you pass any of this certification, you can use the Open Group logo on your CV or website so that the people know you have achieved this accomplishment. 4. This is our language that TOGAF exam is available in English, Spanish, Portuguese, Chinese, French. 5. The cost to take the combined exam is $600. We will now explain the difference between Part 1 and Part 2 exams. Part 1. The exam is an assessment that measures fundamental knowledge of the standard. 2. A test consists multiple choices question with only one correct answer. 3. The exam consists of 40 questions and has a duration of 60 minutes. 4. To pass the exam, a minimum score of 55% or 22 answers out of 40 is required. 5. The cost of the test is $360. 6. You have to wait 1 month before you can retake the exam. Part 2. The exam is an assessment of your ability to apply the TOGAF standard. The evaluation involves a test that is based on scenario and utilize a gradient scoring method. The gradient scoring in gradient means that you are giving a point for answers that are closer to the correct answer. For example, if there is a question with a correct answer worth 5 points and you choose an answer that is closer to the correct one, you may be given 3 points. This is what is meant by the gradient scoring. 3. An open book examination. An open book exam means that there will be a PDF version that you can refer to during the exam by pressing a button on the screen in front of you, which will open a TOGAF standard PDF. But doesn't mean that you can bring a book with you to the exam or open any book other than a TOGAF standard PDF. 4. The exam comprises of 8 questions and has a duration of 90 minutes. 5. A minimum score of 60% is required to pass the exam. 6. To take the Part 2 exam, passing the Part 1 exam is required. 7. The cost of the test is $360. 8. You have to wait 1 month before you can retake the exam. I suggest to quiz yourself and see how well you do. There is a huge list of key deliverables and terms that will show up on your exam. There also an activity file of key terms deliverable and their definition that you can import into a tool of your choice. All of the definition have been completed directly from the TOGAF standard or the TOGAF version 9 foundation study guide. I can't stress more the importance of flashcards. It greatly decreases the time spent studying. I recommend the use of Anki or Quizlet and is a tool that utilizes what's called space repetition, a specific algorithm for better retention of when you are trying to learn material. It automatically review your work card and it tries to help building strengths very quickly within your capability. The Open Group website offers a free HTML or PDF version of the TOGAF standard, which can be downloaded by creating an account on the TOGAF library. And you must learn how the TOGAF standard was organized and constructed because it will be very useful in the Part 2 exam. Therefore, when open the PDF file, you should know where to look for information and this will greatly help you pass the exam. I recommend reading the section explained in each video after watch it, and every time we explain concept and terminology after the video, go and read them so you can easily memorize them in minutes. TOGAF 9.2 standard concept of 6 parts. 1. Introduction. This part provides a high-level introduction to the key concept of enterprise architecture and in particular the TOGAF approach. It contains the definition of terms throughout this standard. 2. ADM. This part is the core of the TOGAF frameworks. It describes the TOGAF architecture development method ADM, a step-by-step approach to develop an enterprise architecture. 3. ADM guidelines and techniques. This part contains a collection of guidelines and techniques available for use in apply the TOGAF approach and the TOGAF ADM. Additional guidelines and techniques are available in the TOGAF library. 4. Architecture Content Framework. This part describes the TOGAF content framework, include a structure meta model for architecture artifacts, the use of reusable architecture building blocks, and an overview typical architecture deliverable. 5. Enterprise Continuum and Tools. This part discuss appropriate taxonomy and rule to categorize and store the output of architecture activity within an enterprise. 6. Architecture Capability Framework. This part discuss organization processes, roles and responsibility required to establish and operate an architecture function within an enterprise. Let's explain it once again in a fresh manner. There are multiple components that build the standard up. Let's talk about a few of them. The first is the architecture development method, or what we refer to as the ADM. It is a set of phases that are structured in a way to help you build tight requirement, a strong architecture solution, and make sure that the people don't get mad at you when you are halfway through. Through planning, it stops you from waste time. ADM guidelines and techniques are tools that help adapt the ADM for different scenarios. The architecture content framework is a set of deliverable artifacts and building blocks that help you create. The Enterprise Continuum is a library of artifacts. These artifacts can be leveraged and reused, built up, and improved over time. There are specific TOGAF reference models that exist that help you initially populate and kickstart your library if you are start from scratch. Finally, the Architecture Capability Framework is a framework for building a strong architecture practice that includes governance, capabilities, measures, and metrics. What is TOGAF? TOGAF is an architecture framework. It provides the method and tools for assistance in the expense production, use, and maintenance of an enterprise architecture. It is based on a iterative process model supports by best practice and reusable set existing architectures asset. And we can also say is a framework for enterprise architecture. It may be used freely by any organization wishing to develop an enterprise architecture for use within that organization. What is architecture? It has two definitions. One, ISO and IES and IEEE defined it as the fundamental concept or practice of a system in its environment, embedded in its elements, relationship, and in the principle of its design and evolution. Two, the TOGAF standard defined it as the structure of components, their interrelationship, and the principle and guidelines governing their design and evolution over time. So, what is an enterprise? Well, an enterprise is a business or company with the goal of making a profit. Sometimes it's very large. It is collection of organizations that share a common goal. And an extended enterprise can actually include things like funders, suppliers, customers, or partners. Let's explain it once again in a fresh manner. An enterprise is any collection or organization that has a common set of goals, or a process, or operating model, or structure, or skills. And an enterprise could be a government agency, a whole corporation, a diving of a corporation, a single government, a chain of a demography distant organization linked together by common ownership. What is enterprise architecture? Enterprise architecture, on other hand, is the practice and the collection of skills that is used to align technology strategy with the specific business strategy. It's about deliberately making a decision on the way compounds are organized, people and process and supported, and the evolutions of the company is managed. Primarily, being a good enterprise architect means you are doing a lot of listening before necessarily jumping into planning, iteration, and big picture thinking. Your goal is to help executive and managers making tech decisions that are aligned. Let's explain it once again in a fresh manner. Enterprise architecture is the process of translate a business vision and strategy into effective enterprise change by creating, communicate, and approve the key principle and model describe the enterprise future state and enable it operations. Or we could say conceptual blueprint. That's the structure and operating of an organization. The intent of an enterprise architecture is to determine how an organization can most effectively achieve its current and future objective. Let's explain it once again in a fresh manner. Description of an enterprise as a system in terms of its components. There is interrelationship, principle, and guidelines governing the design and its evolution. Usually done to identify gaps between current state, desired future state, provide roadmap for organization to achieve its goals, deliver its objective. Often describe multiple levels of breadth and depth. Enterprise architecture is the structure that can help. At its most effective, enterprise architecture enables effective execution of an organizational strategy to achieve change. Business architecture is a major enables component of an enterprise architecture. IT architecture is a major enable component of an enterprise architecture. Why do I need it? Well, without enterprise architecture, we are missing the glue that bring together multiple parts of an organization, and it is a process. Enterprise architecture also helps the organization respond to change market needs and support the delivery of business strategy it is chosen. It helps give guide on how to take existing proposed and even future vision and make them work together. Let's explain once again in a fresh manner. Because it is effective management and exploitation of information is key to business success and competitive advantage. A good enterprise architecture optimize the fragmented legacy of process, manual and automated to an integrated environment, respond to change, support delivery of the business strategy, enable the right balance between IT efficiency and business innovation. What specifically would prompt the development of an enterprise architecture? Preparation of business transformation or radical infrastructure change, initiate an enterprise architecture review or development. Key people identify areas of change required for new business goals to be met. These stakeholders have area of interest known as concern that need to be addressed. The architect identifies and refine stakeholders' requirement, develop view of the architecture that address those concerns, show trade-offs that are necessary between conflicting concerns. Without the enterprise architecture, it is unlikely that all the concern and requirement will be considered and met. Business benefits. Business benefits from a good enterprise architecture. A more efficient business operation example, lower business operation cost, more agile organization, business capabilities shares across the organization, lower change management cost, more flexible workforce, improve business productivity, better return on existing investment, reduce the risk for future investment. Example, reduce complexity in business and IT infrastructure, maximum return on investment existing business and IT infrastructure. The flexibility to make buy or outsource business and IT solution, reduce overall risk in new investment and their cost of ownership, a more efficient IT operation example, lower software development support and maintenance cost, increased durability of application, improve interoperability and either system and network management, improved ability to address critical enterprise-wide issues like security, either upgrade and exchange of system components, faster and simpler and cheaper procurement. Example, buy decision are simpler because the information governing procurement is readily available in a coherent plan. The procurement process is faster, maximize procurement speed and flexibility without sacrificing architectural coherence. The ability to procure heterogeneous multi-vendor open systems. The ability to secure more economic capabilities. Let's explain it once again in a fresh manner. There are three primary business benefits. I break them down into efficiency, harmony, simplicity. From an efficiency standpoint, you become less reactive to change and you are better at risk management. You panic less, you have better capabilities, which means a standard of excellence for everyone is higher. It makes it a lot of either to upgrade and exchange components that have been designed on a common architecture and with a goal in mind. And with the reduced cost of ownership, that's a good planning. It will give a higher return on any invest for dollar that is spent. On the harmony side, it improves the portability of applications. There is better renewability of the infrastructure that's get installed, and it is much easier to work with multi-vendor solution because they all understand the building blocks that you have created. This reduces complexity for both business and IT. From a simplicity standpoint, it is quite simple. Good planning helps make better decisions. It makes them more structured. It makes them more transparent, and it holds the people accountable. It makes it a lot of easier to hit the goal that you set out to achieve. What is a framework? It is a structure for content or process that can be used as a tool to structure thinking, ensure consistency and competence. Why do I need a framework? You might be asking yourself, why do I need a TOGAF framework or any framework for that matter? Well, TOGAF simplified development by provide a toolkit. It makes sure that you don't miss anything during plan, building, and run phases. It helps making decisions that can scale with the future needs. and sometimes it is required as a part of regulatory or government. Key components of a framework include: it should build a common language and set of tools that everyone can use and apply in the same way. It is nice to be able to go into a meeting and be able to pick up where someone left off. It is also nice to be able to design in a way that you can grow and scale your design using things like modular design principles. We can talk building blocks and put them together so that small, simplistic ideas can generate grand design. Typically, a framework should also be able to recommend standards and complement products so that everyone building in a way that people expect things to be built. What is an architecture framework? An architecture framework is a foundational structure or set of structure which can be used for developing a broad range of different architecture. It should describe a method for design a target state of the enterprise in terms of a set of building blocks and for showing how the building blocks fit together. It should contain a set of tools and provide a common vocabulary. It should also include a list of recommended standard and compliant products that can be used to implement the building blocks. Let's explain it once again in a fresh manner. Framework is a structure for content or process that can be used as a tool to structure thinking, ensure consistency and competence. Architecture framework is a conceptual structure used to develop, implement, and sustain an architecture. May be used to deliver a broad range of architectures. Should contain a method for design a system in terms of a set of building blocks, a method for showing how the building blocks fit together, a common vocabulary, a content framework. Let's explain it once again in a fresh manner. Is a tools that can be used for developing a broad range of different architecture. It should describe a method for designing an information system in terms of a set of building blocks and for showing how the building blocks fit together. It should contain a set of tools and provide a common vocabulary. It should also including a list of recommended standard and component products that can be used to implement the building blocks. Architecture domains, BDAT. We also want to cover the four architecture domains, BDAT: business architecture, data architecture, application architecture, technology architecture. This is referred to the business domain, where we talk about things like strategy, governance, and key process. Following up, the data domains refer to the logic and physical assets that we have and the management of those assets to make sure that the things are not lost at the right level of quality and ready for systems to use. The applications domains talk more about the interaction and relationship to core business process and how they support strategy. Applications is more people oriented and skills oriented rather than IT oriented. The last one, technology, is where the applications and technology exist. It is where we talk about things like software, hardware capabilities required to support the business, middleware, network communication, processing standard, and all the stuff that an engineer love to discuss. Together, BDAT, business data application and technology, from the foundation of TOGAF. Let's explain it once again in a fresh manner. Business architecture, application architecture, data architecture, technology architecture. Business architecture defines the business strategy, governance, organization, and the key business process. Application architecture provide a blueprint for the individual application system to be deployed, their interaction and their relationship to the core business process of the organization. Data architecture describes the structure of an organization, logical and physical data asset and data management resource. Technology architecture describes the logical software and hardware capabilities that are required to support the deployment of business data and application service. This include IT infrastructure, middleware, network communication, processing standard. Let's explain it once again in a fresh manner. Business architecture, application architecture, data architecture, technology architecture. Business architecture include business strategy, governance, organization, key business process. Application architecture include a blueprint of application, interaction to other application, relation to business process. Data architecture include the structure of logic data asset, structure of physical data assets, data management resource. Technology architecture include software and hardware capabilities, IT infrastructure, middleware, network communication, a process and standard. Architecture content framework. Describe the TOGAF content framework, including a structure meta model for architecture artifacts, the use of reusable architecture building blocks, and an overview of typical architecture deliverables. The architecture content framework uses the three categories to describe the type of architecture work product within the context, deliverables, artifacts, and building blocks. The content framework is intended to provide a detailed model of architecture work products, drive greater consistency in the outputs that are created when following ADM, provide a comprehensive checklist of architecture outputs that could be created and so reduce the risk of gaps within the final architecture deliverable set, help an enterprise mandate under architecture concept terms and deliverables. Let's explain it once again in a fresh manner. A detailed model of architecture work product, including deliverables, artifact within deliverables, and the architecture building blocks that deliverables represent. It drives for greater consistency in the outputs of TOGAF. It provides a comprehensive checklist of architecture outputs. It promotes better integration of work products. It provides a detailed open standard for how architectures should be described. It includes a detailed meta model. When you complete a phase in the architecture development method or EDM, there are a lot of different types of outputs that you create. These outputs are categorized as either deliverables, artifacts, or building blocks. Deliverables. A deliverable is a work product that is contractually specified and in turn formally reviewed, agreed and signed off by the stakeholders. Deliverables represent the outputs of projects, and those deliverables that are in documentation form will typically be achieved at completion of a project or transitioned into an architecture repository as a reference model, standard, or snapshot of the architecture landscape at a point in time. We can say a work product that is contractually specified, formally reviewed, agreed, and signed off by stakeholders. Let's explain it once again in a fresh manner. Deliverables represent an overall work product that is agreed to, complete, review, and the sign off by stakeholders. Imagine a deliverable as being something you have to produce. You have to finish at the end of the day, something that you promised. Deliverables can be achieved or even transitioned into an architecture repository, also known as a library when completed. Examples of deliverables include things like reference models, standard, or snapshots. There are a lot of deliverables and key terminology that you are going to be tested on throughout the exam. Deliverables are items that are produced and used across the entire ADM lifecycle. It provides a baseline of architecture in order to better define the activities required when you are going through each of the phase in what they call in the ADM. It acts as a starting point for a lot of our customization. Artifacts. An artifact is a more granular architecture work product that describe an architecture from a specific viewpoint. Example include a network diagram, a server specification, a use case specification, a list of architecture requirement, and a business interaction matrix. Artifacts are generally classified as catalog list of things, matter size showing relationship between things, and diagram picture of things. An architecture deliverable may contain many artifacts, and artifacts will form the content of the architecture repository. We can say architecture work product that describe an aspect of the architecture. Let's explain it once again in a fresh manner. An artifact is a detailed work product describe an aspect of the architecture. Architecture help form the content of the architecture repository or library. Example of artifacts include things like network diagram, machine specification, or use cases. Artifacts actually have three different subtypes. The first subtype is known as a catalog, which is basically a list of things. The second type is known as a matrix. It is more of a relationship diagram that shows how two different parts may be interrelated. For example, how stakeholder and accountability might be interrelated. The three type is a diagram, and a diagram is basically a picture. For example, a network diagram or database relationship diagram. Building blocks are reusable components of work that can be combined. There is two major types: architecture building blocks and solution building blocks. Architecture building blocks basically describe requirements. Solution building blocks, on the other hand, describe components or solution required to implement those requirements. So, a solution building blocks may be an actual piece of software, whereas an architecture building blocks might be something that describes a need. Building blocks improve in level of detail as you progress through the ADM phases, starting from generic to finally becoming organizationally specific. Building blocks are a package of modular functionality with a published interface that's conform to a standard. Building blocks can be used on their own or as part of a sub-assembly. Building blocks typically evolve to exploit new technology as it becomes available. You can really create some very complex design with a series of simple building blocks. Let's explain it once again in a fresh manner. Building blocks represent a potentially reusable components of business IT or architecture capability that can be combined with other building blocks to deliver architecture and solution. Building blocks can be defined at various levels of detail and can relate to both architectures and solutions. A potentially reusable component of business IT or architecture capability. Architecture building blocks. One type of building block is an architecture building block. Architecture building blocks or ABBs define functionality that will be implemented. They capture business data, application, and technology domain requirements. They direct and guide the development of solution building blocks. It also included a statement of any reference the architecture that is being reused. Solution building blocks. Solution building blocks define products and components that will eventually implement the functionality. This is define the implementation, fulfill the business requirements, and are typically product and vendor aware. Let's explain once again in a fresh manner. Architecture building blocks typically describe required capability and shape the specification of solution building blocks. For example, a customer service capability may be required within an enterprise supported by many solution building blocks such as process, data, and application software. Describe required capability and shape specification of solutions. Solution building blocks represent components that will be used to implement the required capability. For example, a network is a building block that can be described through complementary artifacts and then put to use to realize solutions for the enterprise. Represent components that will be used to implement required capability. Components of building blocks. Let's take a look at some of the difference between the two. An architecture building blocks describe fundamental functionality and attributes, whereas a solution building blocks has a specific functionality and attribute. An architecture building blocks has a chosen set and supplied interfaces. Solutions building blocks deals with the implemented set of attributes. Architectural building block and solution building block, when they are used, discuss their interoperability to other architecture building blocks or other solution building blocks. They also do this for any dependency. Architecture building blocks have to reference any dependency that they have, and solution building blocks have to do the same. Both should map to organizational intensity and policies. The architecture development method, ADM. is a figure set of phases, each with its own input steps and outputs. An output can include a process flow, project plan, set of requirements, or other work artifacts. Outputs should be version agreed to and then sign off. Each phases and its steps can be fully tailored to your organization. Or we can see the core of the TOGAF framework, a step-by-step approach to develop and use an enterprise architecture. Or we can say the architecture development method ADM forms the core of TOGAF and is a method for driving organization-specific enterprise architecture. It is the result of contribution from many architecture practitioners. Preliminary, here is what the ADM looks like. We start with the preliminary phase. What this is the preparation and initiation activity required to kick off the ADM and build a capability. Some of our goals include determine the target architecture capability and establish the architecture capability. The way we do this is we start with define the enterprise scope, including figure out who our stakeholders are and those who will benefit from us doing the work. We have to find a sponsor or a flag carrier, someone who's going to help us when we are in trouble. We then define and baseline the business, cultural, organizational, strategic, and financial requirement of the work. We then define the architecture principles that will guide and inform our work. This helps us create the architecture vision. The architecture vision is where we create an approved statement of work that define what's both in and out of scope, identify stakeholders, create a vision, and define specific business goals. Our major objective is to make sure that we get endorsement from corporate management, confirm support of line managers, and develop a vision of the capabilities and the business value that we are looking to deliver. We have to get an approval for a statement of work so that we can make our vision come true. The beginning of process start with a request for work. We then research, verify, and start to gain buy-in to the key business objective and the process that we are looking to support with this work. We used business scenario to identify and articulate what is the exactly that need to be done and what do those requirements look like. Using those some business models, we show exactly how are going to create value in the organization through the work that we are doing. We are going to investigate emerging technology and the impact in how they may be applied and used for the work that we have upcoming. And we describe how new capabilities are going to help us meet our business goals and the overall business and strategic objectives. All of this is based so that the people can get excited, want to be able to work on this, and specifically want to support the work on this. We start our review with business architecture. The business architecture describes the relationship of business, process, and people. It talks about how each of these groups are impacted by the new architecture and a plan for what we will need to do in order to adapt and change the way we might work once the new architecture is in place. Our major objectives is to develop what we call a target business architecture description and candidate for an architectural roadmap. Our overall approach starts with a baseline. This is baseline use pre-existing description if they have existed from previous work. We then apply business capabilities and map them to organizational unit value stream and a plan within the scope of the project. We perform a gap analysis to figure out based on our baseline and our target where are we missing a particular capability scale tool, and we apply the organizational map to figure out who need to be involved, how decisions are going to impact those people, and double check if we have missed anyone from our stakeholder list. During this time, we use a lot of business modeling techniques and we use the architecture repository as our library for reference. Information systems architecture. It's all about describe the change that need to be made to the data and architecture domains for the new work we are doing. It documents current and target data quality, applications specification, and their interrelationships. Our primary goal is to develop a target data architecture and the target application architecture. We also want to be able to describe how the target architecture will enable the two previous phases of business architecture and architecture vision. The overall approach begins with data management, figure out where the best source of data is or and define that system of record, what kind of standard we are all going to adapt, how the data entities will be utilized, where data entities will be stored, the level of integration, the level of quality and cleanliness and filtering, and any transformation steps required. We then look to do some data migration, the level of migration required, the detail on the quality, and again, any clean and filter needed to be able to take our baseline architecture to our target architecture. Data governance considers the structure, management of systems and people. And we make sure to utilize any relevant industry specific areas of our architecture repository that might have more up-to-date knowledge on how to approach. The technology architecture, it documents our comprehensive technical architecture that describes principles, constraints, and draft detailed model. Models might include details about systems, protocols, and processes and tools that have been selected during our previous discussions. Our major objective here is to develop target technology architecture and describe how the target architecture will support all the previous phases and build on all the previous work so that we continue going towards our vision and meeting our strategic requirements. The high level approach is to first of all a gap analysis between baseline and target technology architecture. We then want to look towards our research and utilize some of those emerging technologies We learned about to capitalize on any transformation opportunities. We then utilize the relevant industry-specific and the technology-specific areas of the architecture repository if they exist. Opportunities and solutions is where the rubber started in the road. It is describe how the solutions will be implemented, which vendor are going to be select, which tools the team will utilize, and some sort of migration plan that breaks up all of the effort into specific sub-projects and work packages. Our major objectives here is to generate an architecture roadmap. We also want to determine the approach and if we need to have stepstones or a transition architecture along the way so that we can incrementally achieve our final goal. Sometimes building a house is really tough, but if you break it down into the rooms, it makes it all happen a lot easier, and that's what opportunities and solutions are all about. Within this, we also define our solutions building blocks and our architecture building blocks that are going to be used so that we can create our vision. Our high-level approach is to generate a full and complete gap analysis between all and baseline and target architectures that have been developed in the previous phases. We want to build the full roadmap by logically grouping change into work packet and projects. We then develop any transition architecture or milestone if we are going to use them. Develop an implementation plan and develop a migration plan. This is particular state set all of your implementation planning up. Migration planning. Plans the work to get from current to target state by creating a detailed implementation plan. The plan breaks down work into sub-projects and packages which are then prioritized. Our major deliverables is a full cost, benefit, and risk analysis of moving from our baseline to our target architecture so that we make sure that we can tell our key stakeholders why and what we are doing at each phase and what they should expect to get out of it. We ensure that all of our plans are aligned with the enterprise approach to managing and implement change. During this phase, we also finalize the artifacts, including the architecture roadmap, the implementation plan, and migration plan for final sign-off. Our high-level approach includes meeting with the portfolio and project members to discuss plans, as our dependencies, costs, benefits with the projects and the plan. And then finally to integrate this plan with any other change management approaches in place and used by the organization. It is often your project planning team that might know some of these details. Implementation governance. It provides oversight, monitor, and management during the implementation of the work to make sure it is aligned with the initial goals and vision. We want to be going the right direction, and implementation governance helps with that. Our major objectives is to make sure that we are conformant with the target architecture. We perform appropriate action and management based on any implementation driven change requests, and those change requests come in often, so we want to make sure we don't deviate from our goals. Our high level approach is to be establish a program that's going to enable the delivery of the agreed transition architecture. We typically want to adapt a phased deployment schedule, follow all relevant organizational standards for governance and project management, and define an operation framework to ensure architecture that is implemented is maintained going forward. Architecture change management is all about establish procedure for manage change to the new install system so that it continue to provide lasting value to the enterprise. Now that we have built this thing, we want to make sure that it keep giving us the value that we propose. Our major objective is to make sure that the architecture lifecycle is maintained, and the governance framework that oversees it is properly executed. The capability should meet current and change requirements. Otherwise, we might need to do more work. We might need to improve this system that we have. Our high level approach is we monitor the business growth and understand if we are delivering the value that we originally promised from this project. We classify any change as either simplification changes, incremental changes, or complete architecture change. When we change the existing infrastructure, we use top-down to create capability using money or capital. If we want it to enhance capability, we typically do it from the bottom up through some sort of operation or maintenance activities, or maybe modification to an existing or ongoing project. Redesign should usually be considered if there are more than two stakeholders involved. Requirements management is in the center of all of this phase. It is a repository that connects all of these phases together as they get completed. It helps to validate and govern the output of the phases, as well as provide template to complete the step within a phase. It is a great knowledge base and library of all to use, evolve, and pull from. A key objective of the requirements management phase is making sure that it is actually an operation during all phases of the ADM. You are actively using it to pull idea and reference material from, and you are constantly evolve the reference material and knowledge that exists within it. We want to manage requirements identified during each phase and readily offer requirements reference material so that you can get ideas and use those ideas when you need them. Our high level approach is to first document business scenario. Then we want to interface with the library known as the architecture requirements repository. When we are interact with these components, sometimes we are going to end up utilize commercial off-the-shelf tools, also known as CATs. Now you have a great foundation of the architecture development method. This is reliable proven framework will help you develop architecture that meets the business, organizational, and technical needs of an enterprise all without a break thought. The ADM consists of several phases that cycle through domains. Each phase includes steps that utilize assets from the previous iteration and other frameworks to build strong deliverables. The ADM addresses organelle requirements and vision through very frequent validation. And when you perform validation, you should reconsider scope, detail, schedule, and milestones. There are different iteration types. When you are going through the ADM, the first type we will talk about is around, where we basically begin with a preliminary and go through steps A, B, C, D, E, F, G, and H in order. The next type is in between, where I might start with step A, architecture vision, then jump over to step E, opportunity and solution. Take the information that we discussed there and it is deliverables. Use that to help me perform step B, business architecture, and then maybe update some deliverables from architecture vision before finally contain on step C, information systems architecture. The last iteration type is in place. This is iteration type sticks to one particular phase and continuously improve the deliverables that we output. Architecture vision will then go to version 2.0 and 3.0 and so on before maybe content a business architecture and information systems architecture and so on. For each of this iteration, you need to consider what the breadth of coverage that we will be looking at, how deep and to what level of detail do we need to go. What's the time period that's go to be in scope for this is deliverables, and which architecture domains from the BDAT domains will be involved. Finally, which assets can be leveraged from our libraries and repositories. Version control is very important because it helps keep track of the evolution of things like our baseline and target architecture definitions. The ADM version control scheme can be adapted and modified to work with the repositories and tools that you already have in place. An example of a version control framework is like the one I have on screen now. For documents and draft and outline, we are only going to increment by 0.1. So you might be version 0.2 and 0.3 and 0.4. When you have formally reviewed and approved a set of documents, we are going to increment by a whole number. So version 0.4 could quickly become version 1.0. As we get an additional approval and an additional formal review, we are going to again increment by a whole number, or if we are still in a draft, increment by only 0.1. Where does the overall ADM fit within TOGAF? Well, there are 5 areas that ADM and the TOGAF seem to interact. Let's talk about the first enterprise continuum. The enterprise continuum helps categorize internal and industry reference material on a scale of very generic to very organizational specific. The relationship to ADM is we use the enterprise continuum during execution. Whenever you need to make decision, just take generic building block and tailor them for your specific needs. And when we are interact with stakeholders, the second area is architecture repository. The architecture repository is the implementation of the enterprise continuum. It is the library that holds this material. As a library, it includes reference architectures, models, patterns that have been previously accepted, and any documentation of past work and lessons learned. In terms of its relationship to the ADM phases, often contain reminder to go look in the library and utilize past work. And as you iterate through the ADM, this repository becomes more rich, detailed, and populated because you take things that are generically in the library and you might fit them to your needs and then contribute by check them back into the library. Foundation architecture is all about an architecture of very generic service and functions that includes the technical reference model and the standards information base. The foundation architecture helps populate the technical reference model or TRM and the standard information base or CIB with necessary definition and customization. It talks about what is in and what is out for school based on business requirements and the discussions you have had with stakeholders. Supports guidelines is an extended set of resources, including guidelines, techniques, templates, and checklists. In terms of its relationship to the ADM, it describes how to adapt the ADM process for very specific use in terms of specialty scenarios or specialty architectures. And finally, supporting techniques are tools that efficiently achieve a goal or output. When we are talking about the ADM, supported techniques generally help us with specific tasks in the ADM and the ADM phases. There are many reasons that you might want to adapt the ADM. The first reason is ordering. Sometimes the maturity level of your organization requires that the phases are done in a different order or sequence. Another reason might be integration with other frameworks. Perhaps your organization or industry use a very specific framework and you want to be able to interface with because that's what other people around you know and use. Sometimes you need to integrate it with internal governance. This could be because authorization, risk management, business planning, budgeting, procurement, each of them all have their own way of doing things and change their process is out of scope. You just want to be able to and interface with them. In that particular case, an integration may be helpful. Reading is what is referred to when we make a compromise between existing practice and some of the requirements that the enterprise might already have in place. Sometimes you just want to adapt the ADM because it is just too complex. Has too much to handle all at once. But there is some great idea that you can take out of the ADM and start to implement to make better and strong decisions. And finally, sometimes you want to increase the scalability of the ADM. Maybe the size of your organization is very complex or has multiple enterprise and there has to be specific checkpoint tools and techniques that you want to add to the ADM in order to improve the scalability in the organization you are working with. The need for governance. Let's talk about the need for governance. Compliance with the ADM is critical to governance of the architecture, and that required deliverables are actually being produced as they should be. The architecture board plays an important role in ensure that this method is being applied correctly across all phases of the ADM, regardless if you are using the out-of-the-box ADM or you have adapted it. The management of all artifacts should be supported by controlled environments such as one or more repositories. There are three major areas of a governance repository. The first is reference data. Reference data detailed and has description of character and reference material, and it is used for guidance and instruction during project implementation. The next is the process status, where I can find information regarding the state of any governance process, where we are within it, and how well we are doing. And finally, audit information, which record a completed governance list of all the action that we have done. And it helps us support not only the key decision like the what, but also who is going to be able to do it and the responsible personal assigned. Audit information supports future projects by becoming a guide and reference for proceeding moving forward. Why would you scope an architecture activity? Well, sometimes we have to fall within the authority of the individual team or department that is asking for the work. We might have to change the scope so that we can meet their particular level of authority and their particular level of influence. Other time we might want to scope our architecture activity because we want to better meet the objectives and the initial concerns that were laid out by the stakeholder. Sometimes we want to balance the availability of key resources. Can be important when some of those resources might be assigned to multiple projects. In that case, load balance can be achieved by scope your architectural activity. And finally, some work may be very complex or very difficult, and if we change the scope, we can achieve a quicker and more productive win. There are four dimensions that can be used for limiting scope. The first we will talk about is breadth. When we are talking about breadth, we are asking what specific part of the enterprise should we deal with, which particular organization or departments. The second is depth. What level of detail is it truly required for me successfully? And this is up to designers, engineers, and developers. Can I reduce that level of depth to limit our scope? Or do I need to have the level that's currently specific? Time period is our third dimension for limited scope, because we can ask questions like what is defined in terms of activities and planning, and is our time very realistic in order to achieve the vision. Sometimes instead of a one-shot win, we can look for a stage or transitional approach where we achieve multiple small wins on the way to a goal. The final dimension is in architecture domains. The architecture domains is where we scope in any of our BDAT domains. That's our business, data, application, and technology. The question we will ask here is, do you have time to use all four? When you use all four and again, to what specific level in depth? When we talk about integration framework, it is all about grouping architectures that help us create a consistent frame of reference. When defining a single architecture, you are already familiar with addressing the four scope of BDAT, breadth, depth, architecture domains, and time period. If you are looking to integrate framework, we must address them using those exact same four boundaries. The Enterprise Continuum. The Enterprise Continuum is a view of the architecture repository that provides methods for classify architecture and solution artifacts as they evolve from generic foundation architectures to organization-specific architecture. We can say the architecture continuum illustrates how architecture are developed and evolve across a continuum ranging from foundation architectures through common system architectures and industry architectures and to an enterprise own organization specific architectures. Or we can say a categorization mechanism useful for classify architecture and solution artifacts, both internal and external to the architecture repository, as they evolve from generic foundation architectures to organization-specific architecture. Let's explain it once again in a fresh manner. Any architecture is context-specific to individual customers, to industries, to subsystems, to product and surface. A view of the architecture repository, methods for classify architecture and solution artifacts, internal and external to the architecture repository, from generic foundation architecture to organization-specific architecture. The Enterprise Continuum provides a consistent language to communicate the difference between architectures, to organize reusable architecture and solution assets. The Architecture Continuum, a part of the Enterprise Continuum, a repository of architecture elements with increased detail and specialization. The TOGAF framework identifies the following four types of architecture to indicate the range of different types of architecture that may be developed at different points in the continuum: foundation architecture, common system architectures, industry architectures, organization architectures. These are not fixed stage in its process. Apply across all architecture domains, business, data, application, and technology. Solution Continuum. A part of the Enterprise Continuum, a repository of reusable solution for future implementation effort. It contains implementation of the corresponding definition in the Architecture Continuum. Solution represents the detailed specification and construction of the architectures. Solution architectures are populated with reference building blocks, precious or developed for the enterprise architectures. Moving from left to right is focused on building solution value. Moving from right to left is focused on address enterprise need. Classified assets related to the context of the enterprise architecture. Contextual assets may include policies, standards, strategic initiatives, organizational standards, enterprise level capabilities. Architecture Continuum provides a consistent way to define and understand the building blocks with generic roles, representation, relationships. This is a traceability and integrity of the architectures. Solution Continuum provides a consistent way to describe and understand the implementation of assets and building blocks as a result of agreements with customers and business partners, commonalities and difference between products, systems, and service. Deployed solution or instance of the solution within a specific context. Foundation architecture, architecture of generic components, interrelationships, principles, and guidelines, which form the basic foundation for the architecture, on and from which more specific architectures and architecture components can be built. The TOGAF ADM is a process that supports specialization of such foundation architecture in order to create organization-specific models. The TOGAF Technical Reference Model (TRM) describes a fundamental architecture upon which more specific architectures can be based. Common System Architecture use surface and foundation architecture to create an architecture useful for building common solutions across a wide number of relevant domains. TRB architectures, security architecture, network architecture, management architecture, operations architecture, integrated information infrastructure reference model. Industry architectures, integration of common systems components with industry-specific components, retail industry architecture, energetics, oil and gas data exchange standards, organization-specific architecture, describe and guide the final deployment of solution components for a particular enterprise. NBA bank architecture, your organization architecture. Foundation solutions, desktop products, ID services, common system solutions, management solutions, email security, solutions that can be used to build multiple applications or to a common use such as integration platform. Industry solutions, telecom-oriented product mediation platforms (ERP for telecoms), insurance-oriented solutions, policy management solutions (ERP for insurance), organization-specific solutions, solutions that will only work for your organization. Let's explain it once again in a fresh manner. Foundation architecture. Architecture of generic components, interrelationship, principle, and guidelines which form the basic foundation for the architectures, on and from which more specific architectures and architecture components can be built. The TOGAF ADM is a process that supports specialization of such foundation architectures in order to create organization-specific models. The TOGAF Technical Reference Model describes a fundamental architecture upon which more specific architectures can be based. Foundation architecture characteristics reflect generic components of the enterprise architecture including their interrelationships, principles, guidelines, which provide a foundation on which more specific architectures can be built. For example, define technology standard for implementation the enterprise architecture building blocks. Common systems architecture guides the selection and integration of a specific surface from the foundation architecture to create an architecture useful for building common and reusable solutions across a wide number of relevant domains. Common systems architectures. The TOGAF Integrated Information Infrastructure Reference Model is a reference model that supports describe a common systems architecture in the application domain. Common system architecture characteristics. Each is incomplete in terms of overall information system functionality, complete in terms of a particular problem domain. Example, security architecture, management architecture, network architecture, email architecture. Solutions implemented the common systems architecture constitute reusable building blocks for the creation of functionally to complete information systems. Industry architectures guide integration of common systems components with industry-specific components, guide creation of industry solutions for targeted user problems within a particular industry. For example, telecommunication industry, retail industry, bank industry. Industry architecture characteristic reflect requirement and standards specific to vertical industry. Define building blocks specific to a generic problem domain. Contain industry-specific models, logical data models, process models, applications, business roles. An industry-specific example is a model represents the business function and the process specific to a particular vertical industry. TMF for telecoms industry energetics data model accord standards. Organization-specific architectures describe and guide the final deployment of solution components for a particular enterprise. Extended network of connected enterprise may be a continuum of organization architectures needed to effectively cover the organization requirements. May result in several more detailed organization architectures for specific entities within the global enterprise. Organization-specific architecture characteristics provide a means to communicate and manage business operation across all four architecture domains. Define building blocks specific to a particular enterprise. Contain organization-specific business model, data, applications, and technologies. Provide a mean to encourage implementation of solutions to meet business needs. Provide an evolutionary path to support the growth and the new business needs. Provide criteria to measure and select products, solutions, service. Foundation solutions, highly generic concepts, tools, products, services, and solutions components that are fundamental profiles of capabilities. Services include professional services, training and consulting services, ensure maximum investment value from solutions in short time. Support services ensure maximum possible value from solutions helpdesk. Includes programming languages, operation systems, foundational data structures, generic approach to organizational structure, structure for organized IT operation, common systems solutions, implementation of a common system architecture, a set of product and service may be certified or branded, represent collection of common requirements and capabilities. System solution provide organization with operation environments specific to operation and informational needs. High availability transaction processing, scalable data warehousing systems, enterprise management system product, security system product, software as a service, business process outsourcing, industry solutions, implementation of an industry architecture, reusable package of product and service specific to an industry, made up of system solution and or product and services, augment with industry specific components, example, physical database schema, industry-specific point of service device, industry-specific ready to be tailored to the requirement of individual enterprise, organization-specific solutions, implementation of the enterprise architecture that provide required business function. Unique content to meet varied specific needs of people and the process of organization, support specific service level agreement and the key operating parameters and the quality metrics, key link between architecture development and operation personnel for agreements. Primary purpose of connecting architecture continuum to solution continuum is to build organization solutions from industry solutions, system solutions, products, and services. Let's explain it once again in a fresh manner. The enterprise continuum contained information organized from very generic to highly organization specific. This is include foundation level, common level, industry level, and finally specific to organization. The enterprise continuum typically lives in a library called the architecture repository. It is a collection of architecture artifacts and material. The enterprise continuum is typically split between what we call the architecture continuum and the solution continuum, and both of these two areas have generic and highly specific artifacts. The enterprise continuum allows us to easily reference specific to generic when describe the what, why, and the how of a design. It makes communication with both internal and external stakeholders, enterprises, suppliers, and funders much easier and allows for fast decision making. It also aids in effective use of vanilla products, which we call commercial off the shelf or COTS products. The enterprise continuum consists of assets, artifacts, and solutions produced during the application of the ADM. This include deliverables of previous architecture work done by both you and other enterprise architects. A continuum provides a valuable library of reusable material for you to reusable, adapt, and tailor to your current vision and design. This is why you are always improving. The enterprise continuum has many parts. The first classifies assets for the overall enterprise architecture. It influences but might not be directly used during the ADM development phases. These types of documents include standards, policies, initiative structures, and capabilities. The second part is called the architecture continuum, and it is one side of our pyramid. It defines roles, representation, and relationships using architecture building blocks or APPs. This can help reduce complexity when multiple standards are being referenced by improving feasibility on overlapping, unnecessary, or even redundant processes. The other side of my pyramid is the solution continuum. This is define how to implement the asset in the architecture continuum using this is very modular blocks called solutions building blocks or SBBS. Looking at the solution type in detail, we start with the foundation level. In the architecture continuum, this is a very generic component interrelationship principle or guidelines. And in the solutions continuum, this is typically again generic, but it is a concept, tool, product, service, or solution. We then get more specific and our solution becomes a common level. In the common level in the architecture continuum, we use this type of solutions to help guide selection and integration of specific services from our foundation architecture. On the solution continuum, are typically a set of reusable products and services that provide organizations with vanilla operating environments. The next level is industry. In the architecture continuum, industry level solution help guide the integration of specific industry solution for a very specific customer problem. On the solutions continuum, is typically ready to be tailored, ready for organizational use, and already includes some of the components, products, services, and systems that are made just for that industry. And finally, the highest level of specification is the organization solutions type. On the architecture continuum, is a very detailed document that describes and guides the final deployment of components for a specific organization. On the solution continuum, this is usually contain components that have been very tailored and are very unique to an organization. It is people and culture and it is process. The relationship between the architecture and solution continuum is as stated. The enterprise continuum helps improve productivity through leverage. The architecture continuum specifically offers a consistent way to understand the components, whereas the solution continuum offers a consistent way to understand the products, systems, services, and solutions. Together, the architectures and solutions continuum both provide this productivity and leverage. When we are talking about the ADM describes the process of developing enterprise-specific architecture by iterates through specific phases. There is a give and take relationship here. On the take side, during an ADM phase, the architect can reference generic architectures and solutions from the enterprise continuum to help guide and design. On the give side, as the final product design and deliverables get defined, the ADM contributes to the enterprise continuum by improving the assets and evolving them to become more specific. Architecture repository. An architecture contains storage capability that manage all of the architectural information of an enterprise, including data and process model, other enterprise information. Allows an enterprise to distinguish between different types of architecture assets that exist at different levels of abstraction in the organization. One part of the wider enterprise repository, which provides the capability to link architecture assets to components of other repositories, design, deployment, service management. There are 8 classes of architecture information here within the architecture repository. Architecture meta model, architecture capability, architecture landscape, standards information base, reference library, governance log, architecture requirements repository, solutions landscape. The architecture meta model describes the organizationally tailored application of architecture framework, include a method for architecture development and a connect framework and meta model for architecture content. The architecture landscape shows an architecture view of the building blocks that comprise the enterprise architectures at a particular point in time. The architecture capability defines the structure, rules, responsibilities, skills, and processes that support governance of the architecture repository. The reference library provide guidelines, templates, patterns, other forms of reference material can be leveraged in order to accelerate the creation of new architectures for the enterprise. Can use the architecture continuum as method for classification. The standard information based capture the standards with which new architectures must comply. May include industry standards, product and service from supplier or shared services already deployed within the organization. Three classes of standard: legal and regulatory obligation, industry standards, organizational standards. The governance log provide a record of governance activity across the enterprise. Decision log, compliance assessments, capability assessments, calendar, project portfolio, performance measurement. Architecture requirements repository provide a view of all authorized architecture requirements which have been agreed with the architecture board. Solutions landscape present an architecture represent of the SBBS support the architecture landscape which have been planned or deployed by the enterprise. Let's explain it once again in a fresh manner. The architecture repository consists of 8 classes of information. The first is the architecture meta model. This is described a tailored application of an architecture framework, including a meta model for architecture content. The second is architecture capability. This is described parameters, structures, and processes that support the governance of the overall repository. Next is the architecture landscape. Describe a list of building blocks that are currently in use within the enterprise at any point in time. The standards information base describes standards which new architectures must comply with. The reference library is reusable material such as guidelines, templates, and patterns. The governance log is a record of all governance activity that's kept in one place for easy audit, decision making, and transparency. The architecture requirements repository is a library of all authorized requirements which we have agreed to with the architecture board. And finally, the solution landscape is a list of all the current and proposed solution building blocks that are currently in use as an organization. The three levels of architecture landscape, including strategic architecture, segment architecture, and capability architecture. Strategic architecture is all about the long-term view of the integrated enterprise and where it is going to go. This is help with very strategic decision making. It organizes operational and change activity for us. Segment architecture has more detailed models for areas within an enterprise and helps with sub-project and program management. Capability architecture is an overview of current capability versus where we want to go with our target capability. It helps understand how sub-projects and the work package inside them will help us achieve the target capabilities. The standard information base is the architecture landscape that produces best practice standards. The standards are stored in the standard information base. During project design work, you have to comply with all of the standards in the base. Standards should be written in a clear and ambiguous manner so compliance can be binary. You either are compliant or you are not compliant. Having a standardized set of tools is important. It helps promote the reuse and either communication between you and stakeholders. Enables sharing of architecture and solution information. It makes architecture easier to maintain and it allows you to use models when respond to stakeholders' requests. When we are talking about guidelines and principles, let's first understand what architecture principles are. This is our rules and guidelines developed during the preliminary phase. Like a mission statement, principles, once stated, are rarely amended. There are enterprise principles and architecture principles. Enterprise principles harmonize decision making and dictated how the organizational mission will be fulfilled. Architecture principles, on the other hand, govern process affecting development, maintenance, and use of the enterprise architecture. Here is an example of an architecture principle. There are a couple different sections, include name, statement, rationale, and implications. The name should be written in an easy to remember, simple, clear, and concise manner. We typically avoid referencing specific platform, software, or technologies. For example, we might name a principal self-serve. Then there is statement. That statement is supposed to succinctly and ambiguously communicate the principle. For example, for self-serve customers should be able to serve themselves. Rational is include to help business benefit of adhering to the principle become known. In my example, if we had self-serve, it would improve customer experience and reduce our overhead. The implication section talk about what is in it for in terms of resources, costs, and activities for those carrying out the principle. For example, if you carry out the principle of self-serve, it will improve the ease of use. It will minimize corporate training required for our stores and it allows us to over cross-selling opportunities during checkout. When it is stated like this, self-serve becomes very easy to understand and the value is very clear. This is what makes a good architecture principle. Business scenarios. Business scenarios describe a problem in a way that help others understand the value of a solution. A good scenario is smart. That is specific, measurable, actionable, realistic, and time-bound. On the screen, you see a table of questions that we should ask when we are gathering, analyzing, and reviewing our data for a business scenario. This is include understanding what is the problem, what is the environment that the problem is happening in, what are the objectives and goals, who are the human actors and people involved, What are the computer actors and infrastructure that's currently in place? And what are the rules and responsibilities of each of these actors? In each of these phases, we want to be able to answer data and describe that problem so that people can recognize what they should do. Business scenarios play an important role through the ADM, specifically the architecture, vision, and business architecture sections to create business requirements. Gap analysis. Gap analysis is a technique that validates an architecture being developed. Gaps are shortfalls between some baseline and a target that is omitted, accidentally left out, or perhaps not yet defined. There are different sources for gaps. Business domain gaps can exist within people, processes, tools, information, measurement, financial system, and facilities. Data domain gaps can be all about the relationship, the creation or consumption of data, the location of that data, the level of quality or currency, or even type of data. Application gaps could exist with applications that might be impacted, eliminated, or created to your architecture work. Technologies impacted is similar in that we look for things that are impacted, eliminated, or created as a result of your architecture work. To perform a gap analysis, we first start with making a chart to show the architecture building block that exists in the current baseline shown on the left versus the target baseline shown across the top. If an architecture building blocks exists in both the baseline and the target, we consider it include and mark it as so. If an architecture block exists only the target architecture but not in the baseline architecture, it is marked as no. If an architecture building block exists only in the baseline but not the target, we should review it to make sure it is not something that we have forgotten about or missed. If the architecture building blocks is not missing and intentional, we mark it as intentionally eliminated. Interoperability requirements describe the level to which information and services are shared. They are categorized as operational, information, or technical. The architect ensures that there are no interoperability conflicts, especially with respect to the reuse of solution building blocks or commercial off-the-shelf products. Interoperability requirements come into play in the different phases of the ADM. Typically, so this is our phases A through F. In the architecture vision phase, interoperability is eliminated when we are talking about the niche and security consideration for information and service exchange. In the business architecture phase, we discuss interoperability when we are discussing about the information and service exchanges as they are defined in the business terms. In information systems architecture, interoperability is discussed in two areas. In the data domain, when we are talking about the content of the information and the data exchange model, as well as the application domain, when we talk about the way that the applications share their information and services. In the technology architecture phase, interoperability is implemented when the technical mechanism to prevent the information and service exchange are discussed. In the opportunities and solutions phase, we discuss interoperability when we discuss the commercial of the shelf bucket vendors and during their selection process. And finally, in migration planning, we discuss interoperability when we are implementing logically. Transformation readiness assessments. Transformation readiness assessments help us determine what vector will impact a business transformation and if we are ready to have this transformation occur. It is best complete in a workshop session where there are lots of participants then around that can reuse, reject, augment, or replace a list of factors. This type of discussion usually leads to a lot of opening thoughts about a planning. There are different hidden factors listed on screen. An example of some might be vision, urgency, build need, the correct amount of funding, do we have the right sponsorship, the governance model, do we have IT capacity, or do we have HR capacity to be able to handle the work? When we use a chart like this, not only can we discuss the stats of a readiness factor and the areas of concern, but we can also brainstorm some actions so that we can become ready. This prevents this type of workshop from becoming a compliance session and being a more productive sessions. A maturity model is typically the result of readiness assessment and it helps us frame a conversation with stakeholders and subboards. It focuses on the action step required to realize the target architecture. We typically use a maturity model that starts with level 1 and goes to level 5. The different levels include reactive, where we are just doing things based on our best effort. Ad hoc, where perhaps we are doing very well at managed process and policies, but only on specific projects. To define where we are proactively manage our process in people through well-documented and coached standards. To finally, level 4, where we are managed and our processes are measured and controlled. And number 5, where we are considered optimized and we focus on continuous improvement as an organization. Typically, on a maturity model, you list the current baseline of where you are at, as well as the target where your architecture work will help you get to. Risk management is an important aspect of your work. It focuses on identifying, classifying, and mitigating risks. Readiness assessments and capability maturity model help surface and identify these risks through the rich discussion you have with the people involved. There are two types of risk we document. The first is an initial risk, which is the risk before taking any action. And the second is residual risk, which is the risk after taking some mitigating action. For each identified risk, we discuss the effect and frequency to arrive at a final corporate impact risk. Typically, we will use a scale like extreme, high, medium, or low. And there is a symbol of this on your screen. The effect is listed on the left, which goes from negligible, marginal, critical to catastrophic. And across the top is frequency, which starts with unlikely, seldom, occasional, likely, and frequent. The chart helps us understand our corporate impact risk by putting the effect and frequency and outputting the letter that correspond to corporate impact. We then document our mitigation action and recalculate the impacts to see if our plan has made an agreeable difference. The risks have to be approved by the government's framework before mitigation action can be implemented and or begins. Using a before and after chart can really help in making your thinking visible. Here is how you do it. Take a page and split it in half. On the left side, talk about your initial risk. Write down the current risks that you have, the effect, frequency, and impact of those risks. And on the second half of the page, write down any mitigation actions you can think of. You will also document the effect, frequency, and impact of the residual risk or what's left. If your mitigation action and the plan are taken by using this kind of chart, it makes it very easy to communicate with stakeholders and executive exactly how you plan to perform your risk management. When we discuss capability-based planning, there is a couple of different key terms and definitions that we need to be aware of. The first is the corporate plan. The corporate strategic plan drives our architecture vision. Having a vision is great, but we can't do this without capabilities. Capabilities end up defining how work can get completed and who can complete it. So when we are talking about capability-based planning, we are basically trying to understand if we can actually achieve the architecture vision, which then achieve the corporate or strategic plan. When we are talking about capabilities-based planning, we want to focus on business outcomes from a top-down perspective. The challenge when we are doing this is focusing on improving capabilities across a wide range or different departments, not just a single line of business or single department. In my example, product management, marketing, and sales all have a gap around the customer data management. This is a rich opportunity to improve capability in that area. It's going to take time to deliver capabilities, and like project, you need to transition them in increments. Each increment has a strategic plan that should improve people, processes, and material. For my customer data management capability on screen, I show three different increments, and each of this increment has a people, process, and material plan defined. Each increment that we produce should deliver some sort of quantifiable, visible, and discrete outcome. Good governance will ensure that the capability plan is being well executed and that we are actually growing our capability across multiple dimensions at a time. The spider diagram on the right shows each incremental jump and the improvement that we see across different dimensions. Architecture governance is all about how architectures are controlled and managed. It includes systems that enable controls over compliance with standards, management support process, and practices to ensure good, strong accountability. It typically exists within hierarchy and interacts with other things like corporate governance, technology governance, and IT governance, which all could coexist at an enterprise. It also may exist at different levels of geography, such as global, regional, and local. Why do we need architecture governance? Well, there are quite a few benefits. The first is that we can better control risk management. It also maximizes the reuse of existing components. You get greater shareholder value and it ends up becoming part of your organization secret sauce or what makes you special. It improves proactive control and management. And also, good governance leads to better monitor, measurement, evaluation, and feedback. This adds control capability, increase transparency of accountability, and informed delegation of authority. Overall, good strong governance means improved decision making and visibility between the requirements. When we talk about governance from a conceptual structure, it is a content agnostic approach that focuses on six key processes, including policy management, compliance, dispensation, monitoring and reporting, business control, and environmental management. The process ensures integrity and effectiveness of the organization architecture. From an organizational view, organizations need to be well organized in order to support governance. The key area of develop, implement, and deploy is the responsibility of typically one or more group in the organization. For example, the develop area may be controlled by architecture board, which in turn has chief architect, enterprise architect, and domain architect supporting them. The implement key area might be assisted by project management office. In turn, the project management office has the help and support of senior project manager, subject matter expert, and the project coordinators. The WK area might be assisted by the service management team. The service management team has multiple function and grouping of problem managers, incident managers, and event management system and tools to assess them. Each of this area interacts with the enterprise continuum. So you wish to establish an architecture capability. Great. Like any business, this is require functional and operational guidelines. Functional guidelines are strategic guidelines and framework. And operational ones are rules, responsibilities, skills, and processes. The architecture capability framework has multiple components. The first is an architecture board, which has to have guidelines for how that board should operate. There is architecture compliance, which has to have guidelines for how the compliance will be achieved. When architecture contracts are written, we have to have guidelines for how they will be written, documented, and the manner in which they will be negotiated. Architecture governance has guidelines for who and how we are going to provide oversight for our projects. Architecture maturity model include guidelines for where our growth milestone and stage will be. And finally, the architecture skills framework has to have guidelines for what skills and knowledge staff need to possess. Running an enterprise product like a business requires strong capability and very knowledgeable staff. Typically, the staff have to be in financial management, service management, resources management, quality management, configuration management, performance management, risk management, communications and stakeholders management, supplier management, and environment management. This entire orchestra of people will assist you in making sure that your enterprise practice not only runs like a business but a strong one. An architecture capability should be an ongoing effort, not a one-off project or a phase of a project. It requires the compilation of design activities in each of our BDAT architecture domains. For our business architecture, we have to have activities related to governance process design, organizational structure design, and the products for the practice. In data architecture, we have to define the structure of enterprise continuum and architecture repository that are going to be used by the practice. The application architecture will specify the functionality required to enable the practice. And finally, the technology architecture will specify the specific infrastructure and deployment requirements that are necessary to build our architecture capability. The architecture board helps oversee the implementation of governance strategy. It is representative of all the key stakeholders in the architecture. The goals and responsibilities of the architecture board include a basis for decision making on architectures, improving the consistency between sub-architectures, encouraging and setting targets for the reusable of components in the library, enforcing compliance, improving the maturity level of the organization, provide an escalation point for decision making, monitoring and controlling architecture contracts, and finally ensure that architecture is treated as a discipline and not an afterthought. Architecture contracts themselves outline deliverables, quality, and fitness for purpose. The architecture board is involved in continuous monitoring of the integrity, change management, audit, and decision making for these contracts. Contract should always be aligned with the principles, standards, and requirements of the overall organization and enterprise. Architecture compliance. There is different level of architecture compliance that we can discuss. The first is irrelevant. The description of this is that the implementation has no corresponding specification to adhere to. The second is consistent. In this case, the implementation overlaps with some of the specification. Compliant is when the implementation is similar than the full specification and meets the specification. Conformant is when the implementation is much bigger than the actual specification, but it still meets the requirements of the specification. Fully conformant is when the implementation matches the full specification, no more, no less. And finally, what you don't want to hear, non-conformant. Non-conformant is when any of the above situations exist, but the implementation goes against the specification in any manner or size. The compliance review. The compliance review process is a 12-step process to catch early errors, ensure application of best practices, identifying, communicate gaps and stats, and help everyone work better as a team. The steps are laid out on the slide. It includes starting with an architecture request, then identifying the organization that's going to support it, identify a lead architect, determine a scope, tailoring our checklist, scheduling an architecture review meeting, interviewing the project principals, analyzing those completed checklists, preparing a report, presenting our findings, and finally accepting review and sign off, and creating a summary report. Let's talk about a few key definitions. The first is the concept of a system. The definition of a system is a combination of interact elements organized to achieve one or more state purposes. An example of this would be a communication network. A system has one or more stakeholders. The stakeholders are individual teams or organizations that play key roles in and might have concerns about the overall system. An example of a stakeholder can be HR, quality control, the IT team, or executive. Concerns or issues requiring clarification. This is could include a problem to solve, a decision to make, a risk to avoid, or an opportunity to exploit, or an action to take. Concerns are held by stakeholders. An example would be I would like the network fast enough to send lots of videos. Architecture views are a visual representation of a system that show stakeholders that their concerns are being met. For example, there is a picture of a network diagram. See how we have designed it? Doesn't it look like it could transfer a lot of fast video? Architecture viewpoint, on the other hand, are generic templates for an architecture view. Architecture viewpoint help frame concerns. For example, an architecture viewpoint could be visual template of network objective, describe a model technique, a list of concerns, and the stakeholders involved. The architecture view creation process is as follows. We start out by first reference the architecture repository for anything that we can use. Then we select key stakeholders, interview, and document their concerns. We select the architecture viewpoint that best meets those needs and use it as a template. Using the viewpoint as a template, we then generate a view of the system. We have to make sure that the view addresses all the concerns of the stakeholders and documents any trade-off in the design approach. Architecture patterns are like recipes. They identify different combinations of building blocks that have been successfully used in the past. They reference how to use combinations of building blocks, the when, the why, and the impact and trade-off of doing so. As the underlying building blocks evolve, so does the overall quality of solution and the pattern that they can provide. Using TOGAF with other frameworks. There are two primary goals to a framework. The first is that it should define deliverables that an activity should produce. And the second is it should describe a method for the production. Since TOGAF is framework agnostic, you can tailor it. This is really helps fill in the gap and provide the how when using frameworks with detailed deliverables. Components of foundation architecture. Let's talk about foundation architecture. Foundation architecture reflects general requirements and building blocks. It defines technology standard for implementing those building blocks and provide directions for product and services. It reflects the function of a complete robust computing environment. It also provides open system standards, directions, and recommendations. It reflects the overall direction and the strategies that you can implement. The Technical Reference Model or TRM is one such model. It is a foundational model and set of consistent terminology for generic platform services. Because it is very platform centric, it focuses on services and the structure of the underlying platform and can be used to build more specific system and architectures. The Integrated Information Infrastructure Reference Model is a common system architecture that focuses more on applications instead of platforms. This is great because it is addressing the digital transformation work that a lot of architects are being asked to do in today's day and age. A key drive of the development of this model is the need for getting information to the right people in a secure, timely, and reliable manner. This is known as boundaryless information flow. Boundaryless information flow. There are two goals for boundaryless information flow. The first goal is integrated information so that different and potentially conflicting information and the data is minimized across all the systems. The second goal is integrated access. This is so the staff can access information they need through one convenient interface.